So I now see you muted, so now we can start. So hello everyone, it's a pleasure to participate in this meetup, though I actually don't see anyone, just see a black screen with the name of Wojciech, but I suppose that you can hear me well. So this is going to be a talk about RBAC, a concept which a bit controversial in Kubernetes, which lots of people hate, because I'll explain later why, but it's a really essential topic, not only for administrators, but also for application developers. So the aim is to just have like a quick overview of the main concepts and just show a basic example with Helm, basically to show also the issues that you can have if it's not set up correctly. So, okay, I'll just share the screen here. And I see it now here. So, okay, let's start. So, first I'm going to go through a very brief introduction. So, well, if we go to the past, I don't know, maybe could it be like 1 year, 2 years ago? Well, right now it's also happening. The Kubernetes popularity, it's growing exponentially, and because of all the features that it had, people were really compelled by all that it offered. But also, because of that, you could find the internet. It was full of examples for pretty much everything, and really easy to deploy from infrastructure applications like Redis, like MongoDB, like more complex elements like controllers, ingress, storage, even network overlays for those who want try to create their own cluster, for example, or working with QADM. Of course, Helm as well. It was really easy to set up. So I think that helped a lot to have very happy users and to have very good experience and be really easy to learn and experiment with Kubernetes. But then one day, what happened is just version 1.6, as I recall correctly, the role-based access control policies, the authenticator, was promoted to beta. That was a big change because also in several Kubernetes solutions like QADM, for example, it was enabled by default. And because of that, well, suddenly all those easy examples that were around the internet, even official ones, suddenly started to, when you try to deploy them, suddenly errors like that will start to appear. Console like service accounts appear, forbidden, a user cannot do this or that. Well, so suddenly this easy, it was a period where basically all that ease of use turned into frustration. It was a period of time, but it was all because of suddenly one day RBAC policies were enabled by default, and not all the examples that were on the internet or pretty much everything will take that into account. So it was a time where pretty much nothing worked, and it was necessary to adapt it to now this new element. But it was, in my opinion, was something really essential to do because it was definitely there was already another solution like ABAC, but when it came RBAC, I think it was a really important moment because suddenly Kubernetes stopped being like a toy where you would try playing. Suddenly it will have an important step in becoming a mobile production ready platform, because it's when we have Kubernetes in our enterprises or we want to work with it in production, it's important to, for example, to be able to control multiple users, to be able to authenticate, to have control of what a certain user can or cannot do, or what operations can or cannot execute. The same can be said about what a pod can or cannot do. We don't want pods to do operations that could compromise the whole cluster. And also in terms of administration, you may want to limit what we what a user can or cannot see. Basically, because now, up until now, and I think most of us who have worked with Kubernetes may probably worked using full administrator privileges, that is, to be able to do everything. And that's not something you expect to do in a production environment, right? So that's why RBAC is important. And first, before explaining the Kubernetes object, there's something that I always like to explain before, because it's something that we sometimes skip when it comes to Kubernetes, and it's the thing about users, how to create a user. Let me see. I don't know if this is right now. So let's begin by that. So when we talk about users, so as I said before, we've been working with full administrative privileges, but in production, we may want to have different kind of users, kind of operation. They need different usernames, different groups. So you may have experience with Kubernetes, and one of the main main concept is that everything can be modeled like an API object. So one may think, well, so if everything can be modeled as a API object, maybe just like we have pod creation, deployment creation, service creation, this basic concept with Kubernetes, maybe there is one kubectl create user, for example. The thing is that it's not the case in Kubernetes, because Kubernetes provides no API objects to user footnote, because there is an API concept like users, but it's not like deployments or pods that support create, read, update, or delete operations. You cannot create, delete, and update them in Kubernetes. So what solution do we have in this case? What can we do? Well, basically, in the case of Kubernetes, it will depend on the administrator. So the Kubernetes will expect that the administrator will set up some way of letting the cluster know when a user is legitimate or not, or belongs to the cluster or not. For example, certificates, TLS certificates, tokens, basic authentication, OAuth 2. There are several solutions. For the sake of simplicity on this talk, I will just go for one of the simplest, which is the certificate-based authentication. And it's also quite common. Actually, in Bitnami, we use it currently for authentication in our clusters in production. So really simple. Many of you may find familiar this concept. So in the cluster, when we create our cluster, when we use Minikube, when we create our own, when we use kubeadm, DKE, etc., 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 what we have is a certificate authority comprised of a public certificate and a private key. And this authority is the responsible of creating certificates for users that will be able to access the cluster later on. So it's the responsible of signing certificates for our users, basically. So when we try to access the API, as we know, it says use kubectl to the API, we will provide the certificates, and if it's signed using this authority, it will be considered a valid user. That's the way that we can use to access Kubernetes as users. The thing is, so down the line, it's just a matter of creating certificates using OpenSSL, Cloudflare Toolkit. I've used basically OpenSSL for example. And okay, so but where do we put the information in that certificate about which user you are, which group you belong to? Well, basically we'll have two important fields. Basically, in the certificate, you'll need to check the common name, the CN, because Kubernetes will interpret that as the username. And you have the organization, and a set of organizations, which Kubernetes will use as the group, basically. So that's how it works. So we have a certificate with common name, organizations, and Kubernetes, if it's signed by their own authority, it will just take the common name, the organization, and will say, okay, this is user Javier, for example, Salmeron is my name, or user Wojciech, or user whatever. Okay, so really fast. I want to go with that because it's not the core of the talk, but what will be a usual process. So basically, a developer will create its own private key and a certificate signing request, in which it will include the metadata we need for accessing Kubernetes. So it will say in that request which username we want, on which group or set of groups we want. Basically, this is our OpenSSL commands. It's not. I have a GitHub repo with all these commands, so don't worry, you can try it yourselves. And then with that request, it will be sent to the administrator, and this administrator, using the certificate authority that we previously mentioned, it will just sign the certificate request and therefore create the certificate for the user. So once it's been signed, that request, it will be sent back to the developer. And therefore, once you have the user, in order to be able to access Kubernetes, the last thing that it needs to do is to configure the kubectl client, which is the one responsible of accessing the API. And how is this done? Using what many of you may be familiar with the kubectl context, which is a pair of credential and cluster. So a context is just that. You say, I want to connect this cluster with this set of credentials, which is with this certificate. That's all. So you will need to download the authority and the certificate. And just with these kubectl commands, you will first configure which cluster you want to connect to, which has this authority. And then you will configure which credentials, which certificates that we created, we're going to use. So first cluster, then certificates, and finally we create a context, which is the union of the two of them. So as you can see here, cluster, which one? Sandbox is called a cluster. Which user? This one, which is just the set of certificates. And that's simply it. That's testing the configuration. So just let me do a really fast demo of that. Yes, here. So this is in the slides, and I can share it later. There's a GitHub repo, so you can experiment. And then I'll just go really fast in the same process. So what I'm going to do first, I'm going to create a directory where I will store my certificates, and I will create a private key as a developer. So with this OpenSSL command, I create my private key. And oh, it's taking a bit long. There we go. And then we create the certificate sign request, in which here you can see that I put J Salmeron, which is my username, and here two groups, devs and tech lead. I decided that these groups to be created. So I create this request, done. And now as an administrator, I will just, because now I have both roles, but now I will just need to sign the certificate. Here in this case, I know where the cluster certificate is because I'm using Minikube. If it was in an external cluster, you will have to connect to the cluster and there perform signing. So let me just sign this. And now we have here, cert Kubernetes Minikube. Here we have the private key and my public key, which is signed. Just really fast, I'm going to just check the contents to see if it makes sense or not. So this command will check the content of the just recently signed certificate. So here, what's interesting about this part? So here we can see that who signed this certificate, the authority of the Minikube cluster. It's here. And here in the subject, we can see user common name, which will be interpreted as user, Salmeron, and two groups, devs and tech lead. So everything that we said, it's here inside. So now with this, I have the credentials to connect to my cluster. So what's the next step is to create the kubectl contents. As I'm using Minikube, the configuration about the cluster is already there. If I execute kubectl config and then here get cluster, if I remember correctly, you can see that there's already an information about the cluster, so I don't have to put it. So what do I need to introduce now? My credentials. So this is the command that will create my credentials. So I'm using here my certificate and my private key. So with that, now I have my credentials. So now I can finally create a context, which is just the union, as I said, of the two. So here I'm saying, this is the cluster Minikube, and these are the credentials that I'm going to use. And now, and that's the final part, now if I execute kubectl config get context, we can see that now I have two possible ways to connect to my Minikube cluster. As an administrator, just as right now, and now as this new user called Salmeron Minikube. So first, as the administrator, you can see that I don't have anything here in my cluster. So let's try to see what happens when I change to this newly created user. So now, if I execute kubectl get pods, I get that dreaded message that everyone was suffering at what I said before, and when RBAC came, which is this. But it says pods is forbidden. User Salmeron cannot list pods in the namespace default, which actually makes a lot of sense, because what have I done up until now? I just created a user, but this user, in principle, I haven't said what this user can do. So by default, it cannot do anything, which, because if not, it will be a security issue, right? So yes, I created a user, but there's nothing this user can actually do. And this is, as you can see, first, before continuing, you can see that it was correctly identified as Salmeron, so it correctly read the certificate. So now that we have this, now this is where we can start playing with RBAC. So we have the user, now let's try to say what this user can or cannot do inside my cluster. So, well, this is what I just saw. No, this computer wants to restart. No, please remind me tomorrow. No, please. Now, where were we? Yes, so let's talk about role access space control. Just like any other RBAC system, in Kubernetes, it's just three elements which are implied. Basically, we have three important groups, which is one of them is the subjects, that is users or processes that want to access the cluster. Then we have the Kubernetes API resources, which are, as we know, paths, deployment services, config maps, secrets, ingresses, etc., etc., etc. And there's a third group, which is the verbs or the operations that we want to do inside over those resources. So to summarize, we have users that want to do a set of operations over a set of resources. That's what we have. So what does RBAC do? Very simple. It just will connect the three of them. So we'll connect user subjects with operations over resources. So for example, we will say that a user can get list pods. That's connecting the three of them. So in order to do this operation, we have several Kubernetes objects that are implied. The first one is called the roles. And what does it do? It connects resources and verbs and operations. So it will define a set of rules, so a set of operations that we can do over a set of resources. And very important, inside a namespace. So, for example, we can say we want to connect, for example, pods and list and get. That will create a role called, for example, pod access. And what are we doing? Just connecting resources and operations. That's all we're doing. So now let's go to the YAML really fast. So, for example, before that, maybe we may want to do any kind of operations over all of the resources in a namespace. That's also possible. And it will be, for example, called a role NSAdmin. So just two sets that we pick elements from each of them. So now, yes, now let's go to the YAML. Shall we? So the first part, the kind API version metadata, is just the same as any other Kubernetes object. The important part is the rules. There we're going to say what we can put. So there we're going to connect it to items. So really simple. What are we going to put in the rules section? Which resources we want to connect and which operations we want to connect. Let's go to the first part. So in this first part, you will specify basically as resources, you will specify API groups and name of resources. And how do you know that information? You will just go to the API reference in Kubernetes, for example, if we want deployments or pods, or in the case of pods. Let's talk about the case of pods. So if we want to, for example, connect pods, it will say, okay, this is the name of the resource and this is the API group. But it will be, in the case of deployment, will be true. This is something, a small exception, but in the case of the group core, you will put just an empty string. But that's the idea, basically. So you have, you will say pods, you can specify it in an array, and the API groups. So basically, and same pods from the group core, which is using an empty string. Don't ask me why, but that's how it works. And if it was deployment, you will put here deployments and group apps. And now the last part, the operations, is just another array. You will say verbs, get, and list, for example. So that's the idea. So role, resources, and operations. So for the other example, so everything, any kind of object in all of the API groups and any kind of operation. You can also use wildcards, for example, which is because we don't want to put all the API groups, all the resources, and all the possible operations. So that's simpler in this case. Okay, so now we have connected resources and operations. So now there's one element missing, which is the users, which is the subjects. There's a second element, API object called role bindings, and it will connect roles with users. And we said that roles are resources and operations. So with that, we have everything connected. We created two roles before, the one to read pods and the one that could do everything, right? So now I could decide, okay, so for example, I want all of them, all of these users, to be able to have the pod access role, to be able to read pods inside the test namespace. And for example, for the case of this user, Salmeron, myself, I want to also be able to do everything inside the cluster. So now I can play not only with usernames, but I can also play with groups. So I can just have this setting set in my cluster. Let's go to the YAML. And once again, we have the common section, the kind API version metadata. And now we have two sections, which is subjects and role refs. Very simple. The first one will be which subjects you are going to be able to do which operations of the resource, which role. So you can apply one role to a set of subjects. Well, so let me, in the subject section, what will you put? So first, you can put users, you can put groups, and later we'll see another one. So it's something like this. So for example, I can say a group called devs. And this API group, well, currently in all of the examples, you will see that we put this API group here because this group element of the API belongs to this API group. Don't be concerned about this section. This is more thought for future improvements of the API. Okay, so now we have a set of subjects, a group, and now we put, well, the element, the role that we want to apply to this user, to this set of users. In this case, the pod access role. So for the other example, the one that wanted to do everything inside the cluster, we can just put a single user and the other role. So let's just go ahead and let's see, because remember, we couldn't do anything. Let's try now to give some power to this poor Salmeron user, okay? So first thing we're going to do is to switch to admin so we're able to do any kind of operation. So now I'm back now and have power. So first, remember that roles and role bindings are meant to be used inside namespaces. So first of all, I'm going to create the namespace. So here I have the new namespace test created. And now we're going to apply these privileges to the Salmeron user. So this is the creating the pod access role and the role binding that we've seen before. You can take a look here. So you can see that it's just the same that I showed before. It's just the same role binding. So user and that. So let's see what happens. Okay, I created a role. I created the role binding. So now I'm going to switch back to Salmeron and see what happens. Okay, can I get pods? No, I can't, because right now it's trying to access the default namespace, and we set that rules to be applied to the test namespace. So let's see what happens now. Yes, inside the test namespace, I can get pods now. And can I, for example, create an Nginx? No, I can't, because the only thing I can do is to get pods. So that's the only thing we can do. So, okay, let's go a bit further, shall we? So I'm going to give it a bit more, I'm going to make Salmeron a bit more powerful by granting the admin this role that was able to do everything inside the test namespace. So now I created this role, which was made of wildcards, remember, and now I bound it to my Salmeron user, and now let's see what happens. Can I create an Nginx image deployment? Yes, I can. So here I do get pods inside my test namespace. Because here you can see that they're being created. It was here all the time. And for example, can I create a service by exposing this Nginx deployment? Yes, I can. I can do everything inside my namespace. So here's my my service. And can I do the same in the default namespace? No, I still can't. As you can see, the operations that I can do are quite limited to my namespace. Okay, so this is what we have right now. we can see that we've parted from a user that can't do anything, and now we have a user that can do certain limited operations inside the namespace. Let's go a bit further. Because we may want also to, for example, to read and get pods, but not in a single namespace, but in all namespace. We may want to access resources that are not bound inside namespace. For example, nodes don't belong to namespaces. Persistent volumes are not namespace objects. So we may want to also have this kind of flexibility and to tell a user what it can do or it cannot do in all namespaces. So as you can see right now, this is more about what it can do. The lack of a role means that it cannot do. So in order to do that, there's a cluster role Kubernetes API object, and it's exactly the same. So it's just connecting operations to API resources, but in all namespaces. For example, the all pod access, or for example, for persistent volumes, you can do everything for a persistent in a persistent volumes, which is in all namespaces. Really fast, what's the YAML? Well, good news, the YAML difference between roles and cluster roles are practically none. So the only difference, of course, is the kind. One is role, the other is cluster role. But apart from not putting a namespace, there's no difference at all. So, well, logic says if we had a role and a role binding, then if we have a cluster role, yes, we also have a cluster role binding, which is once again the same. It's just taking cluster roles and binding them to a set of users, to subjects, apply to all the cluster. So for example, we may want that all users can read all pods, but we only may want this set of administrators, these users belonging to the group SRE, for example. That's the only way to define that a user is an administrator. We might want them to be able to, for example, access or manipulate persistent volumes. Good news again, the YAML is once again quite similar. It's just instead of role, we put cluster role binding. Instead of names, we don't put namespace at all. And instead of connecting roles, we connect cluster roles. That's it. Shall we try now granting more privileges to this Salmeron user? Let's go ahead. Now I'm going to switch to administrator again, because that's the only person, that's currently the only user that can deploy RBAC rules, because right now Salmeron can't. And well, let's do this. Let's let the user be able to read pods in all namespaces. So this is the cluster role that we've seen previously, and that is the cluster role binding as well. So now that I've applied both, can I read the pods inside the test namespace? Yes, I can. Can I read pods inside the default namespace? Yes, I can. Can I do it inside the kube system one? Yes, I can. Oh, the dashboard crashed. I don't know, something about Minikube. Can I get services inside the default namespace? No, I cannot. I can't, because I can only read pods in all namespaces. Can I run a deployment inside the default namespace? I still can't. So that's basically RBAC. That's the most important bits that you need to understand. That we have subjects, we have resources, we have operations, and it's just a matter of connecting all of them. So, well, before finishing, I would like also to show you a bit. I've been doing very simple operations. So now I'm going to also use, for example, Helm charts. As you know, in Bitnami, we work with Helm charts a lot. We have a whole catalog of Helm charts. And now, well, I have Helm installed in my cluster, okay? let's see what I'm going to deploy the chart. So here I'm going to deploy a Helm chart inside the test namespace. Okay, let's see what happens. Yes, in principle, I can access namespaces, but there's nothing I can do. So in principle, no, because why this error? Well, the cause of this error is about that we have a till. As you may know, I don't know if you're going into much detail about Helm, but Helm has a tiller server which is responsible of deploying charts. So I need to do a special operation. So I need to be able to this JSON user to access tiller in order to contact tiller, basically. But first, so what I'm going to use is to grant a bit more privileges to this user. Okay, so I'm going to go to be able to grant the privilege to access tiller. But first, before going into that, I would like to explain some other elements, because sorry, I forgot also to explain. Let me go here just a sec. I'm going here too. I would like to first, before continuing, I would like to also talk a bit about the verbs, because it's true that I've talked about resources, which makes sense. We all know them. We'll talk about the users, which more or less we have an idea. Let me talk a bit about also the verbs. So in order to understand the verbs, it's a set of operations that you can do in the API. I just want to do a small trivia. Unfortunately, I can't hear you, but let's just go a bit through the operations that we can do. So we got list, we got get, we got create, watch, delete, and patch. And so for this operation, for example, kubectl run, which verbs do we need? Over which operations can we do over which set of resources? I give just a few seconds, but we have Wojciech, do you have the audio set?
Yes.
So if anyone wants to chip in, I'll be glad to. So
if anybody the cable, now is the time to answer.
But the thing is that one small thing, one thought, because as you may know, when we use kubectl run, that creates a deployment, but it also creates like a replica set, but also creates pods, right? So, I don't know. So what do you think about what we may need? Let's start. Which resources do you think you may need?
What? Create, Salma?
Create. Okay, yeah, makes sense to create, but create what?
Deployment.
That's all? Are we okay with that?
Probably a bunch more.
If this person says it right, then Wojciech may have to invite him to beer or something. So let's see what happens, right? So yeah, exactly. It's deployment create. We don't need anything else. If you want to know why, then I'll be glad to answer questions later on. Another one. So kubectl get deployments -w, which is the one that waits for deployments to be ready. So once again, logic says that we may need deployments as resource, but which operation do we need in this case?
Get and list. Watch.
List, get, and watch. Yes, exactly. That's it. So because we get pods, we only want to get and list, but if we want to wait, then exactly we need this watch operation. So it will just update the status. And to delete a deployment,
Remove and get, I think.
delete and get.
Delete, yeah.
Okay, delete. Yeah, it's true. We need to delete and we need deployments. But also, in order to be able to delete a deployment, we need to see if the deployment actually exists. So we need get and we need delete in order to delete a deployment. Does it make sense? Next one, to edit a deployment. So it's just when you use kubectl edit deployment, it opens an editor and you can change this parameter that will get updated. So in this case, what do we need?
Get search.
Get and patch. Bingo. Moving on. This one, expose deployment. I want to say it, but yes, you know what this kind of happens. So when you execute this command, now you have a service that points to that deployment, to the pods inside that deployment. So
Create service.
And get deployment.
Exactly. We need to see if a deployment exists, and if it exists, then create a service. Exactly. And my favorite, kubectl exec my pod. This command that you use to enter the container and execute commands there. Let's go to the simple ones. So what if it's to execute operations over a pod? The pod resource must be implied.
Something like pod extensions, I think.
Kind of, exactly. So we need to see the pod exists, exactly, get pods. But also, if you go to the API, there is like an object called pod exec, which is, so you need to be able to create an execution inside the pod. It's an API object that it's something that you don't see in regular tutorials, but if you go to the API, you will see these strange objects implied. So, okay. Also, before moving on, I would like to just have a very few words about cluster role bindings because okay, it's true when we create a Minikube cluster on a kubeADN cluster, GKE cluster, we have an admin user. And how's that possible? It's because that when you create a cluster, you have already some cluster role bindings set by default. So which makes the cluster. So for example, we got this cluster role binding called system basic users, in which basically says that the users belonging to system unauthenticated basically can't do anything, just an empty role. This is not interesting. The one that is really interesting is the next one, which is the cluster admin role, which is what it says. Any subject belonging to the system masters group can do any operation. So what happens if we want to create an administrator user? It will be as simple as just when we create a certificate sign request to put that it belongs to the system masters group. As simple as that. And there's some other cluster role binding, for example, kube controller manager, kube scheduler, kube proxy. Okay, now that we've seen a bit about cluster role bindings and more about verbs, now it will be a bit easier to understand what RBAC I need to configure to be able to use Helm. I need to connect to Tiller, to this server. So because if we do kubectl get pods kube system, you see that it's a Tiller deployment. And Helm, what it does under the hood is to execute kubectl port forward. It's just a port forward, and then it contacts the server. So I need to be able to do a port forward in pods. How is this done using RBAC in a role? basically, you need to create another strange resource called port forward. It's just be able to create a port forwarding. So that's not really what I consider important. It's just so you know that with this RBAC rule, you can create a particular that says now Helm. But I need to switch to administrator first. Okay, now I should be able here to. Okay, now I can do Helm ls. Okay. Interesting. So now I should be able to install, for example, a chart inside my namespace because I can do it, right? And obviously, here it is. So here it is creating the chart inside my namespace. Great. And as you know, you've seen before that I can't create anything inside the default namespace. So in principle, I can't deploy anything inside the default namespace. I can't deploy a chart. So it should fail. Yet it didn't. Which is kind of strange because I can't create deployments in the default namespace, but I created a DocWiki deployment inside the default namespace. It's just it will be as absurd as deploying a chart inside the kubesystem namespace. And still, this dramatic pause here inside my Helm command. Wow. Well, one day. So basically, it will also be able to deploy it, which is kind of strange. Oh, what's going on here? Demo effect. How unexpected. Well, yes, it will be able to deploy inside the kubesystem namespace. So transport is closing. I try again. Oh, something crashed. So this is kind of strange. So I'm going to basically switch to Minikube, and I'm going to try to just reset. I'm going to kill this tiller pod, and I'm going to recreate it again. And if it will allow me, and see what happens. Wow.
Probably forgot about tiller namespace parameter here.
Let me see what's going on here, but I have this too. So it's running, it's restarting. And now it's, okay, now it's being uninstalled. I'm going to reinstall it. And now let's see. Let's start deploying it. As an administrator, it's taking a bit. And wow, now I get this error. So now it's saying that that kubesystem default cannot list compliments in the namespace kubesystem. Okay, so now I also share with you an experience of the frustration that many users get with RBAC. But now, okay, I'll stop playing with you. Let's take a look and see what's happening. Okay. So let me explain once again. Now, let me just go through. Let's go again. What's happening with Helm? Okay, so with Helm, we've got our charts, and these are, and what we do actually is to tell a pod called tiller to deploy it inside our cluster. So what does this mean? This means that me, as Salmeron, I'm not deploying anything. It's this tiller server, the one that is deploying. What does it mean? It means that there is a process inside a pod that is accessing the Kubernetes API performing the deployments, and now that I've reset everything, now it can't. Before we said that we've been experimenting on how to create a user, how to create certificates, and we've been able to play with them, right? But what about a process inside a pod? So do we need, how is this configured? Do we need to provide a certificate to this pod exactly? Do we need to follow the same stack process? Well, for the cases of process in a pod, there is one last RBAC element, one RBAC object that we were missing. And this one, and is, I think one of that causes the most confusion, is the one called service account. Because we said before that Kubernetes has no user object that you can create, delete, and edit. It's true for all cases except for processes inside a pod. For that specific case, we do have an object that can be created, deleted, and updated, only for processes inside a pod. So when you want to deal with the RBAC for processes inside a pod, I repeat myself, processes inside a pod, then you can have you have to use service accounts. Also, it can be used for storing image pulse secrets when you want to access a private Docker repo. But what's important here is that when we have a pod and want to access the Kubernetes API, this is the kind of subject we're going to use. The YAML, quite simple. It's just you specify the kind and a name. That's it. And when we create this kind of service account, what happens under the hood, it's, let me see here, the Kubernetes cluster will create an API token which can be used to access the cluster. So, and will record. Then service accounts can be used just like in role bindings and cluster role bindings, just as users and groups. So it's just exactly assigned. So now we can create service account, create role bindings and cluster role bindings, just like with regular users. And now the only thing that's missing is to configure, to tell a pod to use one service account or another, or deployment. So we need to specify which service account, which user called to that will use to execute will be using the pod. In the pod definition, you can set the service account name, and you can use services, and that's how you specify how it will be able to access the cluster. Why? Because when you specify the service account name, if not, it will use the default. This API token that was created before will be mounted inside the containers. And then the container can use this API token to access the cluster. So now that this, in the case of Tiller, so basically, before it had a proper API token to access the cluster, and when I reset it, now it didn't have the service account configured, so it was using a different token, and now it couldn't create anything. So it was able to create we passed from creating everything to create nothing, basically. So now let's go back to Tiller. So what do we need to properly deploy Helm? We need to create a service account for the process inside the Tiller pod. And now here comes the interesting part. We need to set up RBAC. And now the question is, okay, what operations does Tiller require to work properly? Well, we're talking about Helm charts. So in principle, it could deploy anything in any namespace. So if we don't configure that, then users will not be able to fully exploit the Helm's potential. So we need to be able to, in principle, one may be tempted to have this kind of cluster role binding. So we will say service account, Tiller SA, the subject, and we will use the cluster admin cluster role, which before we said that it was the one that could deploy anything in any namespace. Great. Yeah, that's possible, and that's how it was configured. But look what happened. Me, as the Salmeron user, I was able to bypass all the RBAC settings that I previously established, right? And instead of being able to create pods on deployments and services in one namespace, now I could create everything, even in the Cube system namespace, everywhere. I was able to create. So this is, yeah, it's possible, but it's a danger, as you can see. So because if we have this kind of powerful pods inside the cluster, then any RBAC that we set may be compromised. So Salmeron can do anything, and this could be another user, and then the cluster will become a mess. So that's one thought I want to share with you about the risk of not setting good RBAC. It's not something that obviously the Helm team is aware. They provide alternatives for that. They're in Helm version 3, they want to get rid of this dealer server, and they want to do an alternative way. So because of the concerns of RBAC and the importance of RBAC. Also in Bitnami, we have the Cube solution, which is, I don't know if Wojciech has shown in one the other days, but it's a dashboard where you can use to deploy Helm charts. And it also has an extra configuration to avoid this. So it has it defines some extra elements so the RBAC rules are respected. So we don't have this case. But I wanted to just share the importance of RBAC, of how, and to probably understand that it can be a really important tool to have a production and secure system inside your cluster, Kubernetes cluster. That's it, what I wanted to show. Just a few words about how will we do it. Basically, we will create a service account, and we will just use this cluster role binding, and then it will just work again. So basically, just what I do here is just to create a service account and to apply the cluster role binding. And now, when we use Helm init, we specify which service account it should use. I'm running out of time, so basically, RBAC is a really important element in cluster administration, but there are others. For example, the user certificates in this example is not the best choice. Maybe, for example, using OAuth can provide better authentication mechanisms. Also, we've specified what a user can do or cannot do, but it's really important also to specify, for example, how many pods a user can create, how many resources can we consume. That's not something that RBAC defines. There are other elements like resource quotas, limit ranges that will also define these elements in cluster administration. So we don't start taking all of the resources, for example, one pod. Also, you can also define how pods can communicate. Can any pod see each other? Do we want, for example, that a database can only be accessed by a certain set of pods, for example, the front end, but not any other pods? That's not set up by RBAC. That's set up, for example, using network policies. Also about the use, should the containers be executed as root in terms of Kubernetes user, but system user root, which permissions do the volumes have? That's something that can be defined using pod security policies. And well, so that's other examples. I recommend you to check Kubernetes documentation and also our Bitnami documentation, because we have several how-to guides regarding these administration elements, and we are happy to just reach us, let us know your feedback and which other cases or your cases you have. So I hope that it was entertaining. So thank you very much. Okay, have time for some questions if anyone in the audience wants to ask. But thank you very much for your time.
So, any Okay, so thank you very much, Salme.
Mhm.
Okay, and so I think we can just let me know once the recording is available, and then I will share it with people. And thank you very much again, Salme.
My
Bye.
pleasure.